Welcome, everybody. I'm really excited to be here today to share with you Ruben's thoughts about how service providers need to evolve their packet and optical transport networks to profitably share in this new digital services era. The communications world is going through a real revolution, and we have not seen this sort of revolution in the past. It will enable significant changes in our life and will impact almost every industry and, in fact, everything we do. And I'd like to mention just a few examples of the applications which will drive these sort of impacts. Firstly, e-health and telemedicine. So this is really powered by the ability of IoT to be embedded in the network and the network to pull information from a massive number of devices out there in end users' homes. So initially I see this starting with vital signs monitoring going on for recently discharged patients and those at risk. However, I think we all are used to people wearing vital signs monitors these days. They might call it Garmin, they might call it Fitbit, but they're monitoring your vital signs. And with the right sort of network, information can be gathered and you can start to preemptively monitor if people's health is degrading or not. Then as you move past from this sort of IoT type application, we can start moving towards applications like remote consultations, where you don't need to go into the doctor's surgery anymore. The doctor can talk to you and he can even look at symptoms with the right quality of video, able to start looking at any issues with you. And then that can move on to even more applications. So like looking at how consultants helping people look at what's going on in an ambulance, so they're taken into hospital, and even further forward into the future, remote surgery and stuff like that. A second area, which is of high interest today, thanks to many of us having to be at home, is e-learning. And this requires a high-speed communications network, and it's got to be extremely reliable. It is no good doing some sort of e-learning and it collapses halfway through a session. Also, for e-learning to be really effective, you need to be able to have AR and VR capabilities to really engage the people doing the learning. So this moves learning from just being a desk taught type environment to a truly immersive experience, both in the classroom and at home if necessary. And this will enrich the educational experience and help develop the skills of your population. The third area, which I think everybody's been talking about, is smart cities with a huge variety of services all integrated together, improving public safety across a city and are offering services that help drive down environmental pollution, etc. Smart lighting, smart sewage, etc. This again needs a massive number of IoT devices, but also lots of video. And what's really, really important is you need to collect all this information in real time and get it back to the core of the network where we can integrate single systems into the whole smart city environment. A fourth area, security and law enforcement. And it's vital to do this that the 5G is able to provide secure real-time information to the law enforcement agencies, providing them with the information that they require. So this will range from IoT devices collecting data about traffic and traffic flows through to fixed and mobile cameras looking at vehicle tracking, etc. And we see a rapid deployment of IoT devices and video devices allowing this to happen. Then the final area I'll mention today, but there are many, many more, is e-governance, and 5G enables all aspects of e-governance, from government to citizen, government to business, government to government. And these sort of environments need a rapid flow of secure information. Security is paramount for these sort of things. And 5G mixed with the fixed services allows the government and public systems to be interlinked together to allow this governance to operate in the most efficient way. So these are the visions of the future, but that's not where we are today. And we must face the facts of today. Large parts of the population do not have reliable broadband access today. And the cost of delivering this fixed broadband has been continually challenging to many service providers. 5G, with its fixed wireless access capabilities, offers the ability to drive the cost down of providing this access. So fixed wireless access, providing high-speed broadband, ultra-high-speed broadband into people's home without the need for fixed connectivity. And I've already mentioned The next step up the tree, new 5G services that will change the way we live, make us more healthy, enrich our lives, e-healthy learning, e-governance. In other areas, enterprises are looking to modernize. And as 5G has started to ramp up, enterprises are looking at how 5G can be relevant to them. This varies from commercial enterprises looking to better secure their staff with remote and mobile working capabilities. And they need a secure, high bandwidth connectivity. But you also get enterprises that are supporting business, mission, and even life critical type services. And they are looking or being forced by regulators to become much more smart. Think smart grid, smart water, etc. Really looking to monitor what's happening in their network to greatly improve their operational efficiency. For example, in many countries, the efficiency of the water supply network is not very good at all. In the UK, for example, 30% of the water supply is lost through leakage. IoT devices placed in the pipes allow you to detect leaks as they occur, allowing maintenance to be made very, very rapidly, greatly reducing the amount of water being lost, reducing the fines that the companies are getting. So really, these companies have to move to smart. It's economically sensible for them to do it. And they have an absolute need for the service not only to be ultra low latency and highly reliable. If the thing you're trying to control is teleprotection between two transformers, it better work all the time, and it better be low latency so you know what's happening. You can switch over in a lightning strike. It's also got to be highly secure. These sort of infrastructures are massive targets for the new generation of hackers looking to get into your network and take over. So the networks absolutely have to be ultra reliable, ultra low latency, and ultra secure. And in the next few years, we expect service providers will offer slicing as a cost-effective way of providing a solution for these types of enterprises, with a massive variance between the sort of slice that will be provided to a normal business customer providing connectivity for their end user on the move or at home to these mission critical businesses. And slicing has the ability to provide different types of network for these. But there can't be one, as I just implied there can't just be one sort of flavor of slicing to meet all these needs. The slice for business, offering highly dynamic, high capacity, will be very, very different from a slice offering mission critical type services. And we'll touch on that in a bit more detail a little later. So these new applications and services generate dramatically more bandwidth across the network. In addition, the higher frequencies used by 5G to give the capacity that's needed means they have the radio masts have far less range. So you need far more base stations across the network. This means that there needs to be a new transport network which supports all this extra connectivity, with each connection supporting far more bandwidth than was previously needed. But as we've also learned, 5G is not just about capacity. In fact, capacity is the small bit of the puzzle. These new exciting services, e-healthy learning, governance, etc., are the exciting bit around 5G. And they bring with them totally new requirements for the transport network, such as fast response time, very low latency, high availability, as I mentioned, network isolation, being able to isolate one bit of the network from another, and then the security that I mentioned before. But it's also not just the services that place these new requirements. To promise the ability for ultra high bandwidth to the user equipment, the radios require ultra accurate timing synchronization to be placed across the network, much higher synchronization than in today's 3G, 4G, or even fixed networks. And the whole RAN itself is completely changing and being split apart, virtualized and disaggregated, with the RU and DU and CU being able to be placed wherever it's required. And in fact, the DUs and CU, the distribution unit and the centralized unit, have the potential to be instantiated wherever required, and then torn down again to save network resources when not being used. Very, very dynamic environment. And the core is going, the network is going the same way. It needs to be virtualized and disaggregated so that you can actually only put bits of network in that are required and bits of functionality that isn't required. And then to drive the need for low latency, the only real way potential way of getting low latency is to move the processing closer to the end user. So we see a proliferation now of smaller edge data centers across the network, where you can put compute resources closer to the end user, then instantiate the processing on these edge data centers wherever and whenever required. But this means that the packet and optical network becomes increasingly important. In the past, this network was just static pipes nailed up, you put them in, done. This can no longer be the case. It must be able to dynamically provide all the capacity and connectivity to wherever it's required, and then be torn down again when it's not required. But it's not just as simple as that. This capacity and connectivity must also be deterministic. You must be able to provide this connectivity with the latency or reliability or security or isolation or capacity that is demanded by the policies and parameters for each service. And that must be done on a service by service basis. If you try to build a transport network to meet the lowest latency, the highest capacity, the highest reliability across the network, it would be impossibly expensive. You couldn't do it. So this hints at what we're trying to go with the network. It's got to support all this new diverse complexity, but it's got to drive down cost at the same time. And it's got to improve cost efficiency. So that starts with improved density, reliability, power consumption, and automating network operations so that services can be delivered more quickly than previously. But you've also got to improve the security of the transport network. This virtualized disaggregated network is introducing a whole new set of threat vectors. So security, which was important before, now becomes paramount. And the transport network has to be built to support these mitigate these transport threats. In addition, the 5G transport is designed to accommodate all of these services in a way that drives down costs. So new network approaches are taken. I mentioned edge computing with storage scaled down to consider the edge of the network, and automated operations and SDN, allowing capacity to be allocated where and when it's required, and then freed up when it's not. And then the transport network itself, which never was deterministic with IP traffic, was always best effort. For all these business mission and life critical services, absolutely determinism is key. So we've got a new type of transport network, even on and above this automated connectivity. Network sharing discussions are becoming absolutely commonplace. The only one major way to drive costs down is to share parts of the network, and I'll touch on that in this slide. In fact, so hybrid slicing. I mentioned slicing. Now I'm going to mention hybrid slicing. And hybrid slicing is the ability to support a whole tool set or toolkit of slicing techniques that best meets the services and the operator's needs. Hybrid slicing enables solutions to process massive numbers of different types of services, each of those services with unique needs, and process and transport them in the exact way they require. With slicing, all the services in the network are divided into groups, as you see here on the chart. These groups are called slices, and each group processes services based on the same sort of performance parameters. And hybrid slicing is used to provide both strict and lenient isolation between these groups, giving the operator the ability to meet the diverse service needs, security needs. So we see three main types of need for the hybrid slicing. The first is infrastructure slicing. This is where common transport infrastructure is used. This might be between multiple MNOs sharing the same transport network, or an MNO sharing their transport network with an MVNO, or it might be a network wholesaler leasing transport to multiple MNOs. Clearly, you need isolation between each of these different MNOs. You don't want one network bringing down the performance of another. So if one network is a little bit lack on their security, you don't want a DDoS attack on that network killing the other MNO's network. So you provide isolation between those MNO networks. Second, new upcoming 5G services have some very strict requirements. Ultra reliable, low latency services are key, obvious there. And also have different security requirements. So you want a different degree of isolation between each of those different types of services. So you might have one hard isolation approach for a service which is life critical, remote surgery, and you might have a different level of isolation between a service which is mission critical but not life critical, like traffic light system, managing the intelligent traffic light system. etc. So you've got various slicing techniques there. Then thirdly, as we mentioned before, enterprises currently build their own networks. We start seeing the requirement they'd love to be able to go to a service provider if they trusted them to provide them a secure backhaul network for all of their smart infrastructure. And with slicing operated by the mobile network operators, they're able to go to those guys and get a slice that they can trust to be secure. So in short, hybrid slicing allows the operator to split services between soft slices, hard slices, and any mix in between these soft and hard slices. The advantage of hard slicing is that it provides the deterministic bandwidth throughout the network and creates a physical-like isolation from each and every service. So what sort of a packet and optical transport network is required to meet all of these diverse requirements? The network must support increased network capacity and new high-speed interfaces. You must provide network optimization to maximize the utilization and drive up efficiency. You need enhanced timing and accuracy of that timing. You need the ability to have low latency where required, but not where not required. And hybrid slicing is needed to enable the service differentiation and service isolation in this shared environment. You need programmability of that network to evolve and make it able to support services as and when they're required. But this network also needs to be highly open. The ecosystem for 5G is huge. No one vendor, no one operator provides the whole end-to-end story. This really is a truly open environment. The network, packet and optical network must support that openness. And finally, and yet probably most importantly, a holistic security package is needed that covers the network itself, the management system, and the traffic across the network. And we call this at Ribbon the 5G native packet and optical solution. So just to conclude, 5G will change the way we work, the way we live, and the way we experience things, changing our society and moving us firmly into the new digital service age. Of course, this revolution has already begun, and it is true that this revolution really could be huge. With e-health, immersive education, things like this, it changes the way we are. So it could be as big as and important as the impact of electricity when it first arrived, or the automobile. So the service providers need to move to a ubiquitous services platform to enable this new digital evolution. And this, as we say, is the 5G native packet and optical transport solution. And it will help deliver secure, deterministic services. And this platform is powered by a programmable hybrid slicing underlay that everything transported across the network with. Once deployed, this packet and optical transport network forms a ubiquitous next generation transport platform for all services, not just 5G. With its tool set of slicing technologies, it not only supports all the services that's needed for 5G, it is also able to support all the previous mobile generations, allocating a slice for each generation, perhaps. It also has the capabilities and instrumentation to support all mobile and all fixed services, legacy, current, and even future. The 5G native transport solution will create opportunities for digital service providers who will develop the infrastructure at the right time to support today's and tomorrow's services. Thank you very much for listening. It's been a pleasure talking to you, and I hope you're enjoying your conference.